Welcome to Trigonometry. And remember, trigonometry is the study of triangles. Now, things you may have done in the past before would be finding angles, like say this is 40 degrees, sides, which would be like this would be 1, and maybe using the Pythagorean theorem. All this is part of trigonometry. Now, you may have seen this before, but this is a right angle triangle. And this is because it has a right angle, which is 90 degrees. Now, let's review a few things. So let's review the sum of the three angles on a triangle equals to 180 degrees. The Pythagorean theorem states that a squared plus b squared equals c squared. So remember that. And also, the longest side is called the hypotenuse. Is called the hypotenuse. Alright, that should be review. Alright, this year we're going to extend your understanding of trigonometry a little bit further. So we're going to introduce the sine, cosine, and tangent functions. So you can write them as follows: sine just being sin, cosine being cos, and tangent being tan. That's how you would write these mathematically. Now, each of these functions have a definition. So, sine is the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is just the opposite over the adjacent. Now, you might not know what these opposite, adjacent, well, you know what the hypotenuse is, but we don't know what the opposite and adjacent sides are. Well, let me just explain that real quick. So, let's say we have an angle theta. Theta is just a variable like x. It's nothing fancy, but usually we use it to describe angles. So let's say we have an angle here. Don't know what the angle is, but we're going to use it to talk about this location. Well, the opposite side is just the side opposite to the angle. So this is just the opposite. You know that because it's opposite from the angle. And we have the adjacent. The adjacent is just the side beside the angle. So that's the adjacent. And we have the hypotenuse, which we already know is the longest side of the triangle. Now, don't mix up the adjacent with the hypotenuse. One way you can tell is because the hypotenuse is always the longest side of the triangle, so it will always be bigger than the adjacent. So if you don't know if it's the hypotenuse or the adjacent, just see which of them is bigger. The bigger one is always the hypotenuse. So essentially what these functions are saying is that these are the ratios of the two sides. Now, an easy way to remember it is using the saying so ka toa. So, write out here. So being sine is equal to opposite over hypotenuse. Ka is cosine is equal to adjacent over the hypotenuse. And toa is just tan is equal to the opposite over the adjacent. Okay, so like I said before, these functions just give the ratio of the given sides when you give it an angle. So usually we put like an angle theta, like sine theta, cos theta, and tan theta. And if we give it one of these angles, it will give us the ratio of the two sides. Now, that might not make any sense right now, but I'm going to do a mini simulation to show you what all this really means. So let's say we have an angle here of 30 degrees, and we measure this side to be 1, and we measure this side to be 2. All right, so let's say we want to figure out the opposite side, which is across from the angle. So let's say we want to find the opposite divided by the hypotenuse, and that's just 1 divided by the hypotenuse, which is out here, 2. So the opposite over hypotenuse is just 1 over 2, or just 0.5. Okay. Now let's draw a bigger triangle out here, but with the exact same angle. So as you can see here, it's just a bigger triangle with the exact same angle. Okay, that's out here. Now this is 30 degrees. We measure this side to be 2, and we measure this side to be 4. Okay, now let's measure the opposite over the hypotenuse, and we get 2 over 4. Well, 2 divided by 4 is 0.5. Interesting. Okay, let's draw a third triangle, even bigger this time. Exact same angle, 30 degrees. All right. So once again, has an angle of 30 degrees. This side measured out is 3. This side measured out is 6. Let's divide the opposite over the hypotenuse. And we end up getting 3 over 6, which is just 0.5. So I think you might see a pattern here, but the ratio of the opposite side to the hypotenuse is always 0.5 if you have an angle of 30 degrees. So there's one way we can write opposite over the hypotenuse, and that's just using the sine. So what we can conclude is that we can say that sine of 30 is equal to 0.5. Again, what this is really saying is that if you have an angle of 30 degrees, no matter how big or small you draw this triangle, the ratio of the opposite to the hypotenuse will always be 0.5. Now, you can apply this logic to all the other trig functions, not just sine. The same logic can be applied with the cosine function. So let's find this missing side here for all 3 of them. So let's use Pythagoras. 1 squared plus b squared is equal to 2 squared. And we get 1 plus b squared is equal to 4. B squared is equal to 3. B is equal to square root 3. So this is square root 3. This one, if you use Pythagoras on it, you get 2 square root 3. And if you apply Pythagoras here, you get 3 square root 3. Okay. Now let's find the adjacent to the hypotenuse. Well, for here, the adjacent side is right here, right next to the angle, to the hypotenuse. So that's just square root 3 over 2. Let's do the same for out here. The adjacent side, which is 2 square root 3, divided by the hypotenuse is over 4, which you can cancel to make it square root 3 over 2. Okay. And if we do this side, the adjacent side to the hypotenuse, we end up getting 3 square root 3 over 6, which again you can cancel to make it square root 3 over 2. So we can conclude, if you have a triangle with an angle of 30 degrees, that the adjacent to the hypotenuse will always be square root 3 over 2, no matter how big or small you draw this triangle. Once again, you can apply the same logic to the tangent. The opposite to the adjacent is just, well, opposite to the adjacent is equal to 1 over square root 3. Again, the opposite side to the adjacent is equal to 2 over square root 3. Again, you can cancel these, so you get 1 over square root 3. And again, the opposite to the adjacent, and you end up getting 3 over 3 square root 3. And you can cancel these. So, as you can see, that the tangent, you can write as tangent of 30 degrees is equal to 1 over square root 3. This is what it really means. It means that no matter how big or small you draw this triangle, that the ratio of the sides will always be 1 over square root 3. So, I hope that you can start to make sense that no matter how big or small you draw triangles, if you give it an angle, the ratio of the sine, cosine, and tangent functions will always be the same.